So today I will talk about what can Lagom do for you. And so a little introduction about myself. My name is Renato Cavalcanti. I used to say that each time that I give a talk, I'm not Italian, and it happens very often that people come to ask me questions in Italian after the talk. So I say that to avoid the embarrassment. I don't speak Italian, despite my name. And I even don't have Italian origin. If you are interested, you can ask me about that later. So I work at the Play Lagom team at Lightband, and here's my Twitter and GitHub and email address if you want to reach out later. So about the title, what can Lagom do for you? Does it resonate with something? So that's the scene of the life of Brian, in which they ask, what have the Romans ever done for us? And then the others answer, well, they gave us the aqueduct. Okay, apart from that, what they have ever done for us? Well, they gave us sanitation, and so on and so on. And then they realized that the Romans have brought lots of improvements to their life. So why I'm bringing that into the Lagom talk is that I started with the idea of giving that talk like a year ago. I was at a Scala Exchange in London, and I was speaking with a lot of people from the Scala community that are building microservices. And some of them were using Lagom, some of them were using Lagom, but didn't really understand parts of Lagom and how we were really solving some problems in Lagom. And some of them was just saying, no, I don't want to use a framework, because I can do that myself. I can solve those problems myself. And then those are the most interesting people to talk with, because then I could ask, okay, but how do you process in the view side of your application, the view models? I'm doing like that. Okay, but what about how can you scale up that? How can you have that when you deploy many nodes? I say, okay, I never thought about that. Oh, I guess that I will do that, or maybe I will. I have to figure out. And then you realize that people were saying, okay, I can do that myself, but they don't know exactly the problem, or they didn't have yet time to think about that. And of course, everybody can solve that problem. It's not a rocket science. But Lagom is solving that for you. So I decided to give a talk to explain better what are the features in Lagom. But Lagom is quite a big framework. And the first version of that talk, I realized that I need 3 hours to give the whole overview. So I decided to reduce it a little bit. And today I will only talk about one, and I think it's the most important part of Lagom, which is the persistence API and how we use Akka persistence and the cluster sharding functionality that we have in Akka to distribute the load over different nodes in a cluster. So, little introduction about Lagom. So Lagom is a microservice framework that is built on top of Play. So Play framework is a web framework. Usually you start a Play application, you start a Play project, it's one application that you code. In Lagom, you have at least two, because you are building microservices. You don't have a microservice with one service. So you usually have two or more, and we use, and I'll explain why, the persistence API in Lagom embraces the principles of CQRS, command query, responsibility segregation, and event source. I will not give an introduction of what is CQRS. I will take that as, I will assume it as shared knowledge, but if that's not the case, please catch up with me later on, and then I can expand more. It's built on top of Akka persistence, actually, and it used the Akka cluster sharding to distribute the loads over the cluster. There are two other parts of the talk that I will briefly show, but I will not go in detail. There is something in Lagom called the service descriptor, and here I'm splitting the name in two, because actually there are two parts there. What we call service descriptor is the service descriptor and a topic descriptor. And why I'm splitting that is because we are now working on support for gRPC. It will be available very soon. We are on milestone 4 for Lagom Framework. So just to be brief about that. So we are working in Lightband on support for gRPC for Akka HTTP. So we have an Akka gRPC library now that we are adding support on Play Framework for gRPC, and we are adding support to gRPC on Lagom. And what happens is that the gRPC thing that we are introducing now is what I will call here the service descriptor only. And the topic descriptor, and I hope I will have time for that demo as well. It's an extra demo that I have. It's more about topic broker API in Lagom. And with gRPC, we will kind of have to think in two separate, a service descriptor and a topic descriptor, because I can, instead of using the service descriptor, I can use the gRPC. But I will not go much more in detail than what I just said. That's why I put it in italic. And during the demo, you see how the dev tools work. It's very similar to Play. You have like a command run all that starts all the servers, and you can do tests. I have test kits to help you write tests as well, and so on. It gives the same user experience as Play. So at the end, a Lagom system, as I was saying, it's not one application, but a few applications. So here I created this drawing. You can see that I made it myself. And you have a triangle, a circle, and a square application. And they will use CQRS and event sourcing as the basis of the persistent. And why we want that? Because we want the changes in my service, for instance, the triangle service, I want those changes to be propagated to other services. So I need to represent them in terms of events so I can publish that on a broker. As such, other applications can consume from the broker and make decisions on that. So it's a whole architectural pattern that we promote here of having events as a first-class citizen in your application as such that you can propagate them to others. But why we do that is I want, for instance, if the square application is consuming data from the triangle application, but the triangle application is down, it means that the square application is unusable. It cannot contact the triangle application anymore. So instead, the triangle application publish information in a broker, in most cases a Kafka broker, a Kafka server, and as such that the square application can consume. And then I can shut down the triangle application if I need, and the square is not interrupted, not disrupted. And so as much as you can, you should represent that in terms of events, so others that depend on that information will not degrade because you are down. And of course, you can also call directly, and that's what the service descriptor does. So the service descriptor Lagom is an RPC style kind of API. So you implement you have an interface, and you provide that interface to me, and then I ask Lagom to generate a client for that. And when I'm talking with your service, I just call a method that will give me the results. And that's the part that will, in the future, very soon, we'll be able to use the Lagom RPC service descriptor or gRPC. So it's on you to choose which one you prefer. So basically, that's more or less the big picture of a Lagom application. Of course, I put the triangle, the circle. You can have many nodes. And that's the main point of the talk today. How I can have a Lagom application that I deploy in a cluster and I have many nodes for one single application. So the command side. I will talk first about how other people are doing CQRS. So you have the command side, the query side. The command side, for me, is the most important part. And so let's imagine that I have a model, which is an account. And I have a balance. And there is a command coming in for withdrawing 300 Canadian dollars. And that command, I have a balance, so I will accept it, and I will emit an event. And that event will be persisted and applied to my model as such that my balance goes to 100. Fair enough. And what happens if I have two incoming commands? What I'm saying here is not how we do, but it's how many people have been doing CQRS. So what people do is, so actually we have two threads, two threads each receiving a command. And what usually people do is they fetch the model, they replay the events. Now that I have a model in memory with balance 500, I apply the command. But in the meantime, that is happening exactly the same in another point in my application. And one of them will, if I let it happen, and I save the events, now I will be withdrawing 2 times. Of course, people don't want that, and that's easy to solve. People introduce optimistic locking. So the first one to hit the database wins, the second one will fail. And it also have the problem that that model has to be brought back into memory each time. Of course, you can keep them around, but then if you keep them around, you have to deal with that as well. You have to remove it when needed, and so on. You need to know where it is to deliver the comment to the right place, and so on. So when you do this kind of command handling, you need to have optimistic locking to preserve the integrity of your journal. And that's a costly cast operation. So you have to check and swap data. It's not really swap because you are appending a new event, but before appending the event, you need to check that the previous event has the version number that you have, that there is no other event that was introduced in between. And that's costly. So it's not really append-only journals. You are appending, but you are first reading before you can append. And you have to do that in one transaction. And that gives us very low throughput. Not to mention that very often people have to reload the model each time that there is an incoming command. So with Akka persistence, so to be clear, what Lagom does is it takes what Akka persistence and Akka cluster sharding provides and wrap it in an API that glue everything for you. You can do that yourself. So, yeah, I should have asked it before. Who is familiar with the actor model? And who is really familiar with Akka and Akka persistence? And actor model using another language, like C#. There is an Akka implementation for C#. Nobody? One person? Okay, the Akka implementation for C# has the same features, I think. I never used, but I think there is feature parity with the Akka one. So in general, when you have an actor in Akka, but also in other actor systems, there is only one instance of a given actor. So if I have my model, account model, identified by ABC, I will start an actor and have that model run inside that actor. And I cannot start another actor with that same one, because I will use the ID as the identifier of my actor as well. So the actor system will prevent you to have many of those instances of accounts in memory, okay? First thing. Second thing is that the actor system gets a mailbox, and the withdraw command goes there. So if I'm sending twice the withdraw command, they go first to the mailbox, and they are delivered to the actor in order of arrival. So at the end, the previous example where I have to have an optimistic lock, here I don't have, because the actor system give me, it's helped me to preserve the single writer principle. There is only one of that guy in memory. Fair enough. I process the first command, I change my balance, I take the second command, and now it will be rejected, but because my balance is 200, and I'm not so popular in my bank, and I cannot go below 0. And so it will be rejected. And that is just what Akka will give to you. So, that the actor system will give us the functionality that we need to ensure that we have only one writer, okay? But it's not finished there, we'll see. So, but what it gives to us is first we have truly append-only journals, because I don't need to have optimistic lock anymore, because the actor system is taking care of that for me. Of course, I get much higher throughputs, and I can keep it in memory. I don't need to replay it. When you start an actor, it stays in memory when you're using Akka. And the result of that, we also have to think about, is that nobody will remove it from memory. So you have to think about that as well. Well, you don't, because you're going to use Lagom. But the idea is you bring an actor in memory, it will stay there. And so you don't need to replay it. But because you don't want it in memory forever, at some point it will be passivated. So in Lagom you have a feature, property settings that you say, okay, after 5 minutes, let's say, if there is no command coming in, just remove it. Remove it from memory, and if there is a command coming in, I bring it back into memory. And that's all brings us to the question, who will manage that for us? If I send a command and that model is not in memory, I need someone to know that. Someone needs to know that. Say, okay, wow, it's not in memory. I have to bring it in memory. Or it's time to shut it down. Or when it's shutting down and there is a new command coming in, I need someone to say, wow, I have a new command, but I was shutting down that actor, so I have to bring them back and deliver the command and so on. So you don't have to do that. That is what Akka cluster sharding does for you. And that's why Lagom take persistence and the cluster shard, glue them together to provide all that functionality. So what does that mean, Akka cluster and Akka cluster sharding? So sharding is how I distribute the data. And you have a shard function that decides that this particular model will have to live here, and that other particular model, I have to put it there. But let's imagine that you don't have this functionality. Let's go back to the optimistic lock thing, or not to the optimistic lock, like the naive way of implementing that just using Akka persistence. I have here 3 nodes, each running a different actor system, each with running on its own JVM. I have now 2 commands, me and my wife withdrawing 300, but the first command arrives on node 1, the second command arrives on node 2. I will create a problem here because each of those nodes will bring that account in memory, subtract 300, and at the end of the journal, if I look into the journal, I will see that if I replay my journal, I will go below 0, and that's what we don't want. So how can I now scale up my application, have different JVMs and different actor systems running, but still preserve the single writer principle? So we do that by creating a cluster. So you have that functionality in Akka cluster. Just say, okay, in Lagom, usually you form a cluster by you deploy, and there is one node that will start the cluster formation. We start with node 1, and then node 2 joins, and then node 3 joins. That's just an example. Of course, you can have many more than just 3. But now I have 3 JVMs, 3 actor systems, but they know each other. They know that they should work together. In that case here, we have something that we call a shard coordinator. That is the one that knows where each model should be loaded. Then comes the first command. It goes to the first node, and the shard coordinator says, okay, the account ABC must live here, and it just processes the commands, just deliver to the model there. Now the model, the account ABC, is loaded in node 1. I came, that the first one was my wife, I came second, I also withdraw 300, but my message reached node 2 for some reason. It's not that I go explicitly on node 2. For some reason, load balance forwarded to node 2. And node 2, because it knows that it's in a cluster, it will ask the shard coordinator, where is account ABC? And the shard coordinator say, it should be in node 1. So node 2 forward the message to node 1. And that gives me the illusion that I have one single actor system. When I create a cluster, an Akka cluster, I take all the actor systems on each of them, and I kind of make them behave if they were one-to-one. And there is an important thing here is that the shard coordinator is taking care of knowing where the account must live, if it's already loaded or not, if it has to initialize it or not, and it will also make sure that if the account is being removed from memory, just clean up, you have to, from time to time, do the passivation, it will buffer the message, restart it, and deliver the message. So you don't have to do that yourself. That's just a code that we provide. Now, I have a demo, but I will not start yet. I will just show the code to do that. And then I will show the other side of CQRS, the query side, in which and then I give the demo that goes from A to Z, okay? So let's go to the IDE. So in Lagom, I'm again the account model is as simple as just encode your model in terms of commands and events. So here I will implement this persistence entity, and I say I receive commands of the type account command. I will emit events of the type account events, and my model is the account. I started with balance 0, and then I declare my command handlers and event handlers. And what it does, well, the command handler that accepts a deposit just emits the event deposit that gets persisted. The command handler that receives the withdraw command needs to check if I will go below 0 or not. And if I will go below 0, it will reject the command here. Otherwise, I will emit the event. But that's the basic concept of CQRS and event sourcing. I have a model that receives commands, emit events, and I will persist those events. And now I can make decisions on the events. They are registered as facts. And of course, I have also to teach Lagom how to apply the events, because once I persist, I have to mutate my model. And that's what we do here. I'm declaring that if it's deposit, I will increase the balance plus the amount, otherwise it's a minus. Important to understand is that the event handler always succeeds. There is no validation. If I have an event in the log, in my journal, it means that it was already validated. And I should just apply it. So when I'm applying the withdrawn event, I'll not check if I will go below 0. If I have it in my journal, it's valid. I can just change my balance. So that's the model, as simple as that. Now, if I look, how can I teach Lagom that this thing exists? Here's the Lagom application loader is the place where the Lagom application will bootstrap. It's something very similar to, it's built on what Play does, okay? And I'll not go over all the details here, but I'm just saying here to Lagom, there is a persistent entity of type account. I will not select because it's less visible, I think. Of type account entity. I'm just telling Lagom, I'm registering that here. And that's it. So I create my model and I register. Lagom will start and will prepare that for us. When I want to use it, and now I will show first that. I have here the service, account service, which is where the incoming request will arrive. And I'm just saying, I'm injecting here the registry. And whenever I have a deposit for that account number, I will ask the registry here on that line that I want an instance for the account entity. And very similar with an actor in Akka, where you get back an actor ref. You never manipulate an actor. No, you have an actor ref and you send a message to that actor living somewhere through that actor ref. Here, Lagom will give you a persistence entity ref. Let me put the type here so you guys can see. Here. It's a special Lagom class, a persistence entity ref. I will remove because otherwise I will have problems when I refer to branches here. And then I can send commands to that. So as simple as that, what we have there for free? Well, what is the account? What the persistent entity registry is doing for you is it will create an actor where that entity will be living inside. It's our own special case of actor that is able to do all the hard lifting that is that you need to have that work, and it will put it on a shard. So you don't have to think about Akka cluster of Akka cluster sharding. The registry is already doing that for you. So now, if that application have one node, it works. I deploy another node, and I configure it correctly to form a cluster with the first node, that will just work, because all those things are just sharded, okay? Again, this is just Akka functionality. We are just building on top of Akka persistence and Akka cluster sharding. But we did as such that you just concentrate on the modeling, and you just drop it there, and it works as expected. So now I will go back to the presentation, and I will talk about the other side of the CQRS story, which is the query side. So now I have all the events in my journal, and I need to do things with that. Otherwise, I can only access my model if I know the ID, but I can also consume those events and do things with that. So how does that happen? So we have in Akka this Akka persistence plugin that will create. We have many different kinds of plugin. Lagom support Cassandra and JDBC. Okay, so the table, whatever you're using, my demo will be using the JDBC. The table has many more columns, but I only put here the two most important that we need for today. One that has the persistence ID, which will be a combination of the name of my entity plus the unique ID, and tags. And why I need tags? Because in a journal, I can have many kinds of different entities that I'm persisting there. And at some point, I want to query. And Akka provides you query by tag. That is, say, give me all the events with that tag. So we can start consuming, doing stuff with that. And here, I'm just putting the tag. And that's what people usually do when they do that by themselves. And here's the problem. Well, sorry, that's not yet the problem. So the tags will be like that, and you have something that is a processor, a read-side processor. And what is that? I have a stream of events in the journal, a sequence of events, and you define a processor that contains the logic that you want to execute when such event is delivered. And we, Lagom, take care of the offset. And that's an important concept. Whenever you have a stream of data that has the payload and an offset, we can do this kind of stuff. We can manage the offset for you. If that thing shuts down for some reason and start over again, we know what was the last offset that you processed, so we start from that offset. And you just process. That's basically what a read-side processor does. However, in my previous slide, I have these events. Everybody was tagged with a count event. Everybody goes to the same journal. And I have now, let's say, events from 3 different accounts: triangle, square, and circle. And I want to consume and say, give me everything that has a count event. And I start to consume them all. But if I have 10,000 accounts in my bank, which is a small bank, of course, 10,000 is nothing, well, I have a processor having to consume all those events, so that's a bottleneck. I don't want to have one processor. And then the first question that I was asking for people doing that is, okay, and if you do that, how do you do when you scale up your application? Now I have many nodes, each of them consuming all the events. Not only will be processed them each time on each node, but they are a bottleneck, no? And then they say, well, I will put the processor in a cluster singleton. A cluster singleton is a functionality you have in Akka that guarantees that there is only one of these over the whole cluster. But it's still not solving the problem, because now I have one. Okay, good, I'm not doing more than twice. But this guy is still responsible for processing all the events. So I want a way, I need the means to kind of create a virtual partition over my journal, that I can look to the journal and say, okay, I want events of a count, but not all of them. I want a subset, and I give to this guy to process. And I take another subset, I give to that other one, other processor to go through it. So I need to have the means to create a virtual partition in my journal. And how we do that in Lagom, we shard the tags. The difference from this slide from the previous one is that the tags now, they have a number. And we do that by configuring Lagom with a number of shards for the read-side processor. And it's as simple as we take the persistence ID, which is a string, unique string. We take the hash code, model the number of shards. So if it's 10, those numbers will be from 0 to 9. And what does that give to us is that now Lagom can say, I have 10 shards, so I create 10 processors. So I will not have one processor consume the whole stream, but I have 10. Each of them consume part of that stream. And even better, I will distribute it in the cluster. So the read-side processors in Lagom, they are sharded. And if you have one node and you have a shard number 10 shards, You have one node, and you have 10 of them running on that node. You scale up to 3 nodes, they got spread. You remove a node, the processors that were living on that third node, they are restarted on the first and the second node. So now we can distribute the read-side processing. Can you do that yourself? Of course you can. Akka gives you everything to do that. That cluster sharding that the sharding that we are doing for the processor, it's not rocket science. We have to think about that and say, how do you solve that? And play a little bit and find your own solution. But it's not what people usually do. People just say, I put one processor in a cluster singleton and I'm good. But that's not performant enough. That you pay the price later on. So that Lagom is giving to you. So what we have there, we have sharded tagging, very important to distribute the loads. So we have now distributed read-side processors through sharding. We have a functionality in Lagom that when you see in the demo, the tables are just created for you. You have a place where you declare how to create a table, and you start the nodes, and it will create a table. We usually recommend it more for dev mode, because usually when you are in the real application, you do that beforehand. Of course, the offset management, very important aspect. And those processors, they have a restart functionality. If something happens, because your database is offline, the process will fail. And then it will start over again after some backoff period. And if the database is back, it will continue processing. Same, you remove a node, the processors die, and they are reinstantiating other nodes and restart it. And that's important because this is the kind of thing that you're not dependent on user interaction. The interaction from the user is the command. The command arrives, it persists events, and you want your system keeping processing the events and spreading the events. Okay, demo. So I give the demo where I have here I will. So did I show the service descriptor? No, it doesn't matter. I will show on the next demo because I think I will have enough time. Great. I can relax a little bit more. I have enough, 15 minutes. I have enough time for the demo. Great. So I will start Lagom in like and play. That Lagom application I will open here first. I have here two services. I have an account service here and the account stream service. For the moment, we will only look into the account, okay? But when I do here, run all, let's see what happens. It will start a Kafka, because I will be using, not on that part of the demo. I forgot one thing. Okay, it's not bad. I have here a Postgres running. Let me see. Too late. Well, what happened is I should have done it before. So on the white console, I connect to Docker running Postgres. And what we see here is that the tables are already there because Lagom started and it created the tables. I want to show before, but okay, no, trust me, those tables were just created. So I have here the journal and the snapshot. That is Akka persistence. That is just the Akka persistence that creates that for us. Then I have the account report, which is my table that I put there for my read side model. And I have this read side offsets, and that's Lagom. Lagom created that table because it will use that table to save the offsets. So let's see what we have on that table. And if I didn't make a mistake, it's empty because the whole system is empty. The journal is empty, everything is empty. And I have here some scripts that I can use to hit ABC. I can use that to send a request via HTTP to the Lagom account service, in which I will deposit 1,000 something Canadian dollar to the account ABC, okay? And it succeeded, perfect. And we have here some log, make a deposit of that amount, blah, blah, blah. So what happened there behind the scene is that that account didn't exist. So it arrives the first account command, deposit for this one. So Lagom will, the shard functionality that we have there, say, okay, I have a command for this entity. I decide that this entity will live on that part of my memory space. I will create it there, and I will deliver the command. And because that entity does not have any event in the journal, there is nothing to replay. The first command arrives, the event gets persisted, now I have something in the journal. Let's see what we can see in the journal. Let me make it. Here I have an event. I can see, the event is serialized, okay? We cannot read it. But here's the entity, the ID, and here's the event with a short tag of 4, okay? Yeah. What else happened here that we can see on that thing? That's if I do that. Let me make it a little bit bigger. So on the offset table, I have already an entry there, which is for the tag 4. If I make another deposit, but that time, and I tested it before, so that will work. If I do here, for account ABCD, I have two entities, ABC and ABCD, but on the offset, I have only one entry, because it turns out that the shard for ABC and ABCD, if you take the ID of those two entities, hash code model the number of shards, it is 4. It means that they are going on the same bucket on my journal. They'll all be tagging with event 4, account event 4. If I will add another one, this time DNF, and now I have another processor. What we can see here is that I have two processors, each of them, one that is responsible for processing account event 4, and one that is responsible for all the events tagged with account event 3. Actually, I have 10 of these running, because I have 10 shards. So Lagom created 10 of them. And each of them are consuming a subset of my event log. If I scale up that application, which is not part of the demo, but if I scale up that application, those read-side processors will be distributed over the nodes. Now, I will stop here. No, this one. And I will change my branch. What is that? I'll just revert it. Don't know what it is. I know what it is. I'm changing here the commit, and I will start. Not start. I will first show the code. So there is a difference here now. Okay, I'll show a little bit the service descriptor API. So that's my service in Lagom, okay? And I have, it's a trait in which I define the service call that I have. What I didn't show before, was not there, is on that new commit, is that I have this topic here. And what's the topic? Those are just RPC calls that I can call directly from one service to the other. The balance, for instance, I have an account number that I have to pass, and the service, here is the input type. Not used means I am not sending any payloads, and double is, yeah, that's the balance, yeah, of course, here, deposit. I'm sending a transaction object, that's my payload, and the return of that service call is done. If you see the transaction, it's just an amount. And I have two endpoints, the deposit and the withdraw, I send an amount to it. And if I'm calling that method from another service in Lagom, I would just call a method and pass an object, okay? It's not like REST that I have to pass myself the JSON payload. I pass an object, it gets this serialized to JSON, behind the scenes and send to the other service. But the topic is not for inter-service communication. The topic is the means that I have, me as account service, to say, look, I will be producing events on that topic. It's not a Kafka topic, it's a topic API from Lagom, but we have our only implementation for the topic API is the Kafka. There is one open source for Kinesis, I think, but we supported the Kafka one. So what we're saying is there is a topic here. If you come and you take that topic, you can consume. And Lagom will make sure that that topic, when you're consuming, will be connected to the Kafka broker and consume the events that the other service will be pushing there, okay? And if you have a look on how this is implemented, that's the implementation on the account service, where say, basically, you should read that like, given the shard tags that I have here, create a topic producer that will pull information from the event stream for this tag and that offset. We are just giving a function here, a function from tag offset to a stream. And this is being converted. Each time that I have a deposit, I will put in Kafka just a single line, deposit and account, just to have something visually that we can see. So what is a topic? What the topic produce? How the topic produce relates to the read side processor? It's exactly this. It's very similar in the sense that I have a stream in my journal. I want to consume it, and I have an offset. And for each event that I process, I want the offset to be saved, as such that tomorrow when I restart it, I will restart from that offset. That's the same principle. So, as such, we can use the same idea that we have applied to the read side processes, we can apply to the topic. I don't want to have a topic consuming all my events. I want to have many topic producers consuming my events and pushing things in Kafka. So at the end, because I'm using the sharded tags here, and in our example I have 10 of them, the shard number is 10. At the end I will have 10 topic producers pulling from the journal, processing the events and putting in Kafka. And then I can also distribute it over my cluster. It's exactly the same thing. The only difference is that one is producing views and the other is producing, pushing data into topic. I just realized that I didn't show the read side processor, which is, I'll show you that first before I run the demo. Wait, I will do that. You remember when I declared here the entity in Lagom? There is also that. I'm also declaring the read side processor. Okay? I should have shown it that before, because you already saw that demo, actually. So the read side processor is a class that we implement. In our case here, I'm using the JDBC plugin, and I have this slick read side using. And I'm just declaring there will be something that I will identify by account report. Please create the table when you start. And here's the create table method that will do that for me. And whenever you have a deposit, you go to the repository for the report and you increase. What this report is doing is that for each account, I'm counting the amount of transactions I have, okay? It's a very, very simplistic report. And withdraw, I do the same. I also increase that count. And I give that, and the repository is just putting that on the table, which I will show here, look. If what was again that? If I show here, because we run already that demo, we can see that the account report. You see, account ABC got 1 transaction, ABCD got 1 transaction, D and F got 1 transaction. So I'm creating a view from the events emitted from those accounts. So now I will run the demo that includes the topic. So what's going to happen? We know, because I run the demo for the read side processor, the command side and the query side, so I have already a journal. The processor already processed the the events for those accounts and it's maintaining the transaction count here on the view side. But now I introduce the topic. So what's going to happen is when I start that Lagom application now, the processor will start from where they stopped, the read side process. But the topic, because I just introduced it, it will have to start from scratch. Because if you look here, I only have offset tracking for the accounts. I introduce the producers. We'll see what's going to happen here. Boom. Oh, wait. I'm right. So what happened is that the producer started, they go to the offset, they see that there is nothing there, so they start to consume the events, and I will show the code where I'm just printing doing println of each element in the topic. So if we go here back, I have now 2 entries, and they are doing exactly the same. Why I have 4 in total? I have consumers consuming event 4 for the read side processor and event 4 for the top producer, and the same for event 3, account event 3. And from where this is coming is that on my project, if I open now the account stream service, you see here that I'm getting the account service. It's just a class. I just let it be injected. If I open here the loader, no, I do like that. That's the other service. So I have 2, the account service and the account service stream. And here I say I want Lagom to generate for me a client for this account service. And that client arrives here, and I can just take the topic, that's the topic that I declare on the other side, and I start consuming from that. So what happens is, in one side, I declare how I want to produce the topic. On the other side, I just consume it. And that's all of this, what I have today. I think we have 2 seconds for questions. Sorry.